Hi, I am Syed on Maths Online. Today we'll be discussing about the topic directional derivative. Find the directional derivative of the functions x, y, z along the direction of the normal to the surface xy square plus yz square plus zx square is equals to 3 at the point 1 comma 1 comma 1. So it is given over here. Find the directional derivative of the function. So the function over here is x into y into z. So let us take that surface to be say 5. So 5 will be equals to xyz, this particular function xyz. So now we'll try to find out del phi of this value. So del phi will be equals to, because we need to find out the directional derivative. So you have to find out that del phi value. So del phi will be equals to dou phi by dou x into I plus dou phi by dou y into j plus dou phi by dou z into k. So this will be equals to, so you have to differentiate this given function with respect to x. So when you're differentiating with respect to x, you will get only yz. So yz times of I plus when you're differentiating with respect to y, derivative of y will be 1. So xz will be as it is times of j plus when you're differentiating this 5 with respect to z, derivative of z with respect to z will be 1. So xy, the constant, will remain as it is times of k. So we have got the value of del phi, and we have to calculate this value at the point 1 comma 1 comma 1. So let us try to find out that value del phi at the point 1 comma 1 comma 1. So this will be equals to, so x, y and z, all the values are 1 only. So if you put over here y into z, 1 into 1 will be 1 only. You will get it as I, plus here also x is also 1, z is also 1. You will just be getting j. Here x is 1, y is 1. So you will just be getting k. So we have got the value of del phi. So what is given over here is given along the direction of the normal to the surface. So surface is given. Using this surface, you have to find out this vector. So whenever this vector is given directly, you can use. When the vector is not given, you have to convert that in this form. So let us try to convert it. So for that, we will be taking another surface. So let me take that as psi. So 5 I have already taken. I will be taking the value to be psi. So let psi is equals to, only the left hand side you have to take x y square plus y z square plus z x square. So once again I'll try to repeat these steps. As I have found out del phi value, now I'll be finding del psi value. So del psi value will be equals to, similar formula, in place of phi will be getting psi. So we'll be getting dou psi by dou x into I plus dou psi by dou y into j plus dou psi by dou z into k. So now if you try to differentiate this psi with respect to x over here, derivative of x with respect to x will be 1, you'll just be getting y square value. So you'll be getting the value as y square plus, this term does not contain x value, therefore its derivative will be 0. So this part, this will be 0. Now coming to this one, x square is there, differentiation of x square will be 2x. So you'll be getting the value as 2xz times of this I plus, similarly you have to differentiate this with respect to y. So 2xy you will be getting the first part. The second one, derivative of y is 1, so plus z square will be getting. Last term does not contain y, so its derivative will be 0 times of j you have. Next 5 has to be differentiated with respect to z. First will be 0, I will not be rating 0 value. Next second term, so when you try to differentiate, z square will be 2z, so 2yz plus, so plus x square you get, derivative of z will be 1. So these are the values that you have found out. So once again I'll try to find out this del psi value at the point 1 comma 1 comma 1. So put the value of x as 1, y as 1 and z as 1. So here we'll be getting y value will be 1 square will be 1. So 2 times of 1 will be 2. So we'll just be getting this value. Coming to the next one, it is 2 plus z value is 1. Next value again you have 2 plus x value will be 1. It's times of k you have times of k. So therefore we'll be getting 3i plus 3j plus 3 times of k. So now I need to find out the unit vector along this vector. So let us try to find out the unit vector along 3i plus 3j plus 3k, right? N cap is equals to, so I'll be taking this particular vector, that is 3i plus 3j plus 3k, divided by modulus of the same value. So modulus of this particular value will be square root of, you have to square 3 square. Next coefficient of j is also 3, 3 square. Coefficient of k is also 3, so 3 square, which will be equals to, evaluate the denominator value. So I'm taking 3 common from the numerator, I plus j plus k. Denominator 3 root 3 you'll be getting. So what happens is 3 and 3 will cancel out. You'll be left out with n cap to be equals to I plus j plus k divided by square root of 3. N cap is been obtained. Therefore now I need to find out the directional derivative. Directional derivative. So the directional derivative will be nothing but del phi dot n cap. So del phi value has already been evaluated. So del phi value is I plus j plus k. This is the value we have obtained. Dot n cap. So n cap value is I plus j plus k divided by square root of 3. So this 1 by square root of 3 I'll take common outside. Now since it is a dot product, I'll be taking I dot I will be 1 plus j dot j is 1 and k dot k is 1. So therefore we'll be getting the value to be 3 divided by root 3. Or if you try to simplify this one, 3 by root 3, 3 can be written as root 3 into root 3 divided by root 3. So however you can see this one root 3 will cancel out. You'll be left out only with square root of 3. That will be the required solution. So you should remember, whenever n cap is not given, this del psi value that I have used is only to calculate the value of n cap. So whenever the vector is not given for n cap, you have to calculate using the del psi value. That's all I have for today. Thank you.